All right, so in this video, we're going to talk about Stackelberg oligopoly. Stackelberg is the other um, oligopoly model that we're going to discuss when we're talking about choosing quantity. So, like Cournot, they choose quantity. By they, I mean the firms are competing on quantity. So, the choice is on Q. Now, remember with Cournot, they choose Q simultaneously, so at the same time. However, with Stackelberg, there is a sequential order to the choice. In other words, there's a leader and a follower. So a good example of this is when technology is introduced to the market. Firms rush to be the first to do this because then they have their pick of the markets. So in other words, they can sell as much Q as they want to, and the follower can only respond in a way that will maximize their profits, right? Because remember, all their choices are based on what the other person does. So if the leader produces a Q that is 25, then the follower usually cannot produce as much as that Q. And we'll see that with the equation. They have to pick whatever is left of the market, whatever the leader was not able to produce to provide for the market, and sometimes that might be 12 or some lower number, which means that the leader with the higher quantity ends up with the higher profits. Okay, so a lot of profits compared to the follower. So there's a real life application of this, real life scenario where there is competition to be a leader versus a follower. And as economists, we understand why this relationship happens. And Stackelberg has gone ahead to show it mathematically, this relationship. So what we're going to do is understand this Stackelberg oligopoly model and see what the optimal choices are for the leader, right? For the follower, what price is going to be, what their profit is going to be for the leader, profit is going to be for the follower, right? Okay, so before we go ahead and do all that calculation, we're going to see here, just talk a little bit about how this leader decides the quantity to pick, because we said first things first is that they pick a quantity. So what they typically do is that because they know they're going to go first and the follower can only respond to what they're going to do, what they being the leader is going to do, they're going to choose their output level that maximizes their profits, sure, of course, but it's going to do so at the expense of the follower. So whatever Q they decide, Q star leader, they're going to pick the Q that will help them maximize profit as much as possible, but at expense of follower. So in other words, they will try to get as much of that market as they can, as much of that market share as they can. And the reason they haven't gotten this part is because getting this quantity here is the most profitable for them. All right, so let's look at an example. This is going to follow with the previous example we worked on in Cournot, except now we have a leader and a follower. It's Stackelberg. Okay, so from that example, we had that quantity for the market was equal to 339 minus price. And we know from this that this means that price is equal to 339 minus Q. Okay. We also know the marginal cost is equal to 147. Again, this is just an example that we were given, and we're just following this equation here to see that the profit for this scenario where there's a leader and a follower versus the scenario where they're moving at the same time. So we can compare which reality is better and for who. Okay, so let's suppose that American Airline moves first. then this means they need to know, American Airlines, they need to know how United Airlines will best respond to their choice. And then they're going to pick a queue that will minimize these best respond for United to their choice. So remember, we're trying to do optimality here. Goal is profit max, which means we're looking for MR is equal to MC, or we're looking for the derivative of the profit function with respect to Q being set equal to 0. Okay, same thing, same thing. All right, and we're going to do this for the leader and for the follower. So let's go ahead and start. We've said first step is get the best response function for United, which is going to be a function of American, right? So get the best response function for the follower. The leader calculates the best response function for the follower of the follower. Okay, so let's do that. Remember, the best response function depends on MR is equal to MC. So we need this of the follower, which in our case is United Airlines. So for MR of United Airlines set equal to MC of United Airlines, we know that MC of United Airlines is nicely 147, but for MR, we need that total revenue for United, which is P times Q of United. Remember, P is equal to 339 minus Q, and Q is equal to QU plus QA. Okay, the quantity produced by the leader and the follower. Okay, so that means that price would be equal to 339 minus QU plus QA, which is 339 price minus QU. We're going to apply the negative sign to both terms, minus QA. All right, so let's come back here. We have that our total revenue for U will be equal to, this should be very similar to what you've seen. I mean, this should be reminding you of what you've seen in the Cournot calculation. But we're doing this for the follower first. Okay, so we have 339 minus QU minus QA times QU. So this would be equal to the total revenue for United Airlines, 339 times QU minus QU squared minus QA QU, which means that our marginal revenue for United Airlines will be equal to 339, because this goes to 1, minus 2 times Q. So I'm taking this derivative with respect to QU. So the 2 is going to come down, and we're going to subtract 1. So 2 times QU minus this QU goes to 1. So minus QA. That's our marginal revenue for United Airlines. And so to do that calculation for best response function for United as a function of Americans, remember that this is just, again, best response function for the follower as a function of the leader's quantity, because they can only choose, they should choose whatever quantity for United or follower based on what the leader has done. They're trying to maximize their profit given what the leader has done. Okay, so this would be calculated from the marginal revenue from United, set that equal to the marginal cost from United. So this is 339 minus 2 times QU minus QA is equal to 147. We're solving for, that's right, we're looking for this for the follower, for United. So we're solving for QU. So we have, so in other words, we're taking this term to the other side. 339, and we're bringing this term to the side. Okay. Minus QA minus 147 is equal to 2 times QU. Divide both sides by 2. We have 339 minus 147 minus QA divided by 2 is equal to QU. So we have 192, I believe. Yep, 192 minus QA over 2 is equal to QU. Again, this should be very familiar to you from our Cournot calculations. So we end up with 96 minus QA over 2 is QU. This is our best response function for the follower united. Now that we have that, American Airlines, the leader, is going to use this best response function of United, the follower, directly in their residual demand function. So they're going to choose their, so when they're defining like their marginal revenue for American or leader equal to marginal cost for their leader, this marginal revenue is going to already account for the best response. That's very different from what we saw up here. When we're doing the marginal revenue up here for the follower, we just used a generic QA, right? We're not using that exact best response QA in the follower. But the leader here is going to use the exact best response QU. Okay, so let's see what that's going to look like. Good, good, good. So now we want to figure out, now calculate the BR, actually not best response, the profit, because they already know. They're not responding directly to any given Q, they're responding to a particular Q. So now calculate the QA star for the leader, American. In other words, we need that MRA equal to MCA. Okay, so MC for American is also 147. That's great. Let's get MR. MR for American is the derivative of total revenue for American with respect to American quantity. So let's do that. To do this, we need total revenue, right? Need to erase this. Total revenue for American is equal to P times QA, right? And typically, I mean, we already know that P, I'm going to put this down here too. Excuse me. We already know that P is equal to 339 minus QA minus QU. The thing that's different here is that we're not going to use just QU. We're going to use the best response for U. Okay, so remember from above, we just calculated this. The best response for U, this thing, is this whole equation. So use the follower. The best response for the follower is 96 minus QA over 2. So we're going to use this whole thing in here. So actually, I'm going to rewrite my total revenue down here. So total revenue for American would be equal to P times QA, right? Where P is 339 minus QU minus QA. Since I'm replacing QU, I'm going to put it last. So QA minus QU, same difference, times QA. Critical step here, critical step. So we're doing 339 minus QA. Yep, sure. But we're replacing this QU with this whole best response function. So we have minus 96 minus QA over 2. Now the thought process here is that this leader knows that the follower, who is not choosing at the same time, has no choice but to respond to whatever quantity the leader sets. Right, so the leader sets this quantity first, and the follower has to pick this particular Q follower, which in this case is U, based on the profit maximizing Q leader, which in this case is A, that they pick. Okay, so let's expand this some more. So we're going to apply this QA to each term in the equation, right? So this whole thing. Okay, so we have 339. Maybe I should. Okay, 339. I was going to decide if I should open this parentheses first before opening the bigger one, but either way works. So long as we understand the process here. I will open the parentheses first, and then apply the outside QA. So we have 339 minus QA minus 96. We're applying this negative sign to each term in the parentheses. So that becomes plus QA over 2. All of this times QA. This is equal to, we can collect like terms, so 339 minus 96 minus QA plus QA over 2 times QA. This is equal to, what is 339? Calculator. What is 339 minus 96? 243. Okay, so that's 243 minus, this is a minus because it's a whole QA as opposed to half of a QA. So we have 2 over 2. 2 minus 1 is 1. So minus 1 or minus, okay, minus 1 over 2 QA, which is the same thing as saying minus QA over 2. Okay, and we're going to multiply this by QA. So again, remember this is just total revenue for American. So this would be equal to, now we can apply this QA to each term in here. As you can imagine, applying the QA to each term is much easier, the outside QA, in this equation down here than if we had done it up here. Okay, that's why I opened this parentheses first. All right, so we have 243 times QA minus QA squared over 2. Or if we want to keep things a little cleaner, we can separate the half from the QA so you can see why it's squared. So minus 1 over 2 times QA squared. Same thing. Okay, so this is our total revenue for A, which means our marginal revenue for A will be equal to 243, because this goes to 1, minus 1 over 2 times 2, this 2 comes down, and we're going to subtract 1, times QA. Okay, so this is going to be equal to 243 minus, these 2's cross out, QA. This is our marginal revenue for A. Now, remember that this is the marginal revenue for the leader after they've considered the best response for the follower when using the best response of the follower. Very important step here for Stackelberg. This is what separates it from, this equation here is what separates it from Cournot. All right, so we have marginal revenue for A. We're going to set that equal to the marginal cost for A. So we have 243 minus QA. I just got this horrific thought. What if my Screen was actually not being recorded, but it is, so we're good. All right, so we're going to solve for QA here. For QA, because that's our goal. This is the profit maximizing Q of the leader. Profit max quantity for the leader who chose their quantity based on how the follower is going to respond. So we have 243 minus 147 is equal to QA. So our QA star will end up being 96, but let's use our calculator to check. So we have 243 minus 147. 96. Wonderful. This is the profit max quantity for the leader, which in this case happens to be American Airlines. We could have done this calculation for United Airlines as the leader. The same thought process follows. Okay, so once we know, now we know Q for the leader, QA, is equal to 96, we can calculate the Q for the follower based on the followers, let's be specific, based on the followers' best response function. And we remember that from our calculations earlier that the best response function for the follower is this. Okay, 96 minus QA over 2. So we have that the best response function for the follower, let's do this in blue, who is united. So Q united star here will be equal to 96 minus QA over 2. Once I put the profit maximizing QA, so QA star, that makes this the profit maximizing quantity for the follower united. So this would be equal to 96 minus 96 divided by 2, which is 96 minus 48, which ends up being 48. This is the Q star. Okay. Profit maximizing quantity for the follower. Follower who is united in this scenario. Consistency, I'm going to say UA because that's what I've been calling them. Okay. Now that we have the Qs for these two, if you watch the other video, you remember that for Cournot, it was 64 for both. Okay, just FYI. All right, now that we have the Q for both, we can calculate the big Q star. So this would be equal to Q star for American, the leader, plus Q star for United, the follower. So we have 96 plus 48, which in this case is 144 units. Okay. Once we have Q star, we can figure out P star, which is 339, minus the 144, which in this scenario is $195. Again, so if we're comparing, that's compared to 211 for Cournot. Okay. Back to our calculations here. Once we have our P star, Q star, we can also figure out the profits for the leader, American Airlines, the leader, which would be equal to P. Remember our calculation for profits, and just write this out here. Profits is a formula, P minus average total cost times quantity. So for our leader here, American, this would be Okay, yeah. P minus average total cost for American times quantity for American. So price is 195. They both face the same price. So the passenger pays the same amount regardless of what airline they use. Okay, in this market. Um, Minus 147. We did, how do we know? The question told us earlier that our average cost, okay, we just have to scroll up a little bit more, hang in. Our average cost, yeah, I got it. Our average cost is 147. Okay, bear with me, we're about to scroll further down now to continue our calculation. Okay, times the quantity of, for the liter, that was 96, right? 96, good. So this is equal to, let's get our calculator. 195 minus 147 is 48 times 96 is 4,608. So we had 48 times 96, which ended up being 4,608, compared to the 4,096 that they earned in Cournot, profit from Cournot. Okay, so it looks like life is better for the leader versus the Cournot scenario where we're moving at the same time, which is why there's so much investment in R&D for things like AI technology or there's different innovations that exist in the healthcare industry, in service industry, but technology is a big one where there's that race for being first to the market because of this. But let's see what the reality is like for the follower. So profit for the follower, United, is equal to P minus ATC for the follower, which in this case is United, times the quantity that United sells. Remember, they get the same price regardless. So 195 is the price minus average total cost, which is 147. They have the same cost and the same product. Okay, and the quantity for United is 48. Okay, so times 48. This is equal to 195 minus 147, we already know is 48, times 48, which is 48 times 48, oh, excuse me, 48 times 48, $2,304. $2,304. I mean, when we compare this number to the 4,096 that they would get from Cournot if they're both moving at the same time, or to the amount that the leader gets, we see why there is such a push to be a leader in the industry. Leader as in the person who moves first, the person who comes first to market. Okay, so that's the calculation there. Let's, we already did the comparisons between Cournot and Stackelberg, and so I will stop there. If you have any questions, please feel free to reach out. Good job watching this.